Hello, and thanks for clicking on this next pre-narcosis production. Today we're going to talk about polynomial inequalities. So this is maybe the first time that many of you have looked at this. So let's take a look, see how it works. Okay, there's a trick to it, and we'll talk about how we're going to work on this. All right, so let's take a look at a graph. It's easiest to see what we're going to try to do algebraically with a graph. So the first question is, here's the graph of f of x. I want to know a couple things about it. Where does f of x equal 0? Where's the y value equal to 0? Well, f of x is 0 there and there. We agree? So this is 1, right? Because it's 4 boxes to make 2. So this is 1, and that's negative 2. So at x equals 1 and x equals negative 2. Now, letter B asks, where is f of x bigger than 0? So where is the y coordinate greater than 0 on the graph? So here's the y coordinate. It goes up and down, right? My y coordinate is greater than 0 when the graph is above the x-axis. When it's above this line, the y coordinate is positive. So this graph is actually above the or the x-axis. If I trace it all over here, and then again over there. So we're going to write that as an interval, in interval notation, 2 intervals. We're going to say from negative infinity, x values, to negative 2, in the union with 1 to infinity. Now, I use parentheses on the negative 2 and the 1 because I'm asking you, where is this function greater than 0? And at negative 2 and at 1, it is 0. So these values would not satisfy this inequality. So they don't count. Okay, and finally, where is f of x less than 0? So where is the function or the y value below the x-axis? Just this little piece here. From negative 2 over to 1. Okay, so now, here's what we're going to do. If I ask you to solve a polynomial equation, that means you're going to find the zeros of the equation. That's what we did in letter A. Okay? But what we want to do is we want to work with polynomial inequalities. So to find the zeros of the polynomial, it can help us to determine where the polynomial is above or below the x-axis. Because 0 is really the changeover point, right? Where you go from above the x-axis to below the x-axis, or below the x-axis to above the x-axis. That's where you change over, is at 0. Okay? Our goal is to solve questions like B and C, but we want to do it algebraically without having to make the graph. All right? So this is what we want to try to accomplish. So here's how we're going to set out to do that. Okay? So it's a cookbook. You follow the cookbook, there's a good chance you're going to be able to get the answer. You're going to write the inequality in standard form. So that means you have to have 0 on one side and all of your other terms on the other in order. Okay, degree order. You're going to factor if necessary to find the zeros. You're going to find the zeros. These values, the zeros, are what I call the cut points. They cut the interval into different pieces. Okay, or you cut their number line into different pieces. You're going to use your cut points to divide the number line into intervals. We're going to choose a test point in each interval, substitute it into the function, and determine whether or not the function has a positive or negative value at the test point. So this is the big thing. We're going to do this in just a minute. I promise you it's much easier to do than it is to write. And then we're going to determine which intervals satisfy the inequality. Those intervals are the solution to the inequality. Okay, so here we go. Let's give this a shot. We're going to try to solve x squared plus 5x plus 4 is greater than 18. So we're going to do this algebraically. The first thing we need to do is we need to put the thing in standard form. You have to have 0 on one side, all your terms on the other. So I'm going to subtract 18 over. That's the fastest way for me to get there. And this is what I got. Okay, now I'm going to factor this. I want to find the zeros. Okay, so I want to find the zeros. X squared plus 5x minus 14. That's x plus 7, x minus 2, right? They got to multiply to be negative 14, add up to 5. That's 7 and negative 2. Okay, I want to find the zeros. So I'm going to split it and solve it. So I get a 0 at x equals 2 and another 0 at x equals 7. These are my zeros. Okay, they're also known as my cut points. They're going to cut the number line up into 3 intervals. All right, so here we go. I'm going to make my number line. I got negative infinity. I got positive infinity. I put negative 7 on my number line. I got 2 on my number line. And you can see that my cut points cut the interval or the number line into 3 different intervals. One from negative infinity to negative 7, another from negative 7 to 2, and another from 2 to infinity. So now here's what we're going to do. We are going to pick a point in each, or an x value, in each one of these intervals. Okay? And we're going to call it a test point. So we are going to test, okay, 3 different values. Something between negative infinity and negative 7. So I'm going to pick negative 8. I'm going to test that. Something between negative 7 and 2. I'm going to pick 0. That's an easy one to do. And then something between 2 and infinity, I think I'll just pick 3. So now, here's what I want to do. I want to test each one of these numbers, and I'm going to test it in the equation that's been factored. That's the easiest one to work with because I don't care about what numeric answer I get. I only care about the sign of the answer that I get, whether the answer is a positive or negative. That's all I care about. Okay, so for example, if I put negative 8 into the factored equation, negative 8 plus 7, that's a negative number. Negative 8 minus 2, that's a negative number. A negative times a negative is a positive result. So this interval has a positive result. If I put 0 in, 0 plus 7 is a positive answer. 0 minus 2 is a negative answer. A positive times a negative is a negative result. If I put 3 in, 3 plus 7 is positive. 3 minus 2 is positive. Positive times a positive is a positive number. I get a positive result in that third interval. Okay? And again, you can see, we'll test it down here. I'll show you just in case you're having trouble seeing what I'm doing. So I'm putting negative 8 into the factored equation. There it is. So this is a negative answer. That's a negative answer. The result is positive. I'm putting 0 into the equation. 0 plus 7. 0 times 0 minus 2. That's a positive. That's a negative. The result is a negative. Okay, that's what I'm doing. I do not care what the actual value of this positive or negative number is. I only care that it's positive or negative because I want to know where x squared plus 5x minus 14 is greater than 0, which means that the answer has to be a positive. So the answer is positive in this first interval, not in the second, and in the third interval. So these 2 intervals are actually going to be part of my answer. Now the only other question is whether I count the 2 cut points, the negative 7 and the 2. Well, let's go back to the sign. This says that it has to be greater than 0. At negative 7 and at 2, the answer is 0. So neither one of these count. They get open circles. Remember open circles from Algebra 1 in 8th grade, probably? Okay. They get an open circle there. They don't count. So my solution is going to be the first interval, negative infinity to negative 7, with a parenthesis. It's an open circle. Not the second solution. No good. Or the second interval. And the third interval from 2 to infinity. This is the correct answer. Okay? That's how we're going to do this algebraically. All right? All right, let's try x squared or x plus 4 squared times x minus 2. This has already been factored, less than or equal to 0. It's already in standard form. It's already been factored. I have everything on the same side. So I just want to know where this thing is equal to 0. So I'm going to split these right away. This second one here gives me x equals 2, and the first one gives me x equals negative 4. These are my zeros. They're my cut points. Okay, let's find that make that number line. We got negative infinity, we got positive infinity, negative 4 goes on my number line, 2 goes on my number line. And again, these are my zeros. The question is, is this thing allowed to be 0? Well, it says less than or equal to, so yeah. Back in Algebra 1, you would have made a closed circle on the -4 and the 2, and that's what you should do. Okay, now we're going to pick some points to test. So something between -∞ to -4, like -5 would be good. Between -4 and 2, 0 is always great. And between 2 and infinity, how about 3? We're going to test them in this equation here. It's already been factored. So let's test x equals -5. If I put it in, I get -5 plus 4 squared times -5 minus 2. Well, let's look at this carefully. -5 plus 4 squared. This factor always gets squared. So no matter what kind of number you have inside the parentheses, when you square it, the answer is a positive. So this factor is always a positive number. So the only thing that determines this answer is the -5 minus 2. That's a negative. Positive times a negative, that's a negative. This is a negative result. Let's put 0 in. Again, we have 0 plus 4 squared times 0 minus 2. Well, that's going to be positive again because I'm going to square it. So that's positive. 0 minus 2, that's a negative. That's a negative result. It's negative again. Okay. And then we have 3. Let's test x equals 3. We have 3 plus 4 squared times 3 minus 2. So that's going to be positive. 3 minus 2 is positive. That's a positive result. This is positive here. So we have 2. Let's see. We got x plus 4 squared times x minus 2 has to be less than or equal to 0. So it's got to be negative. It's negative there. It's negative there. Not there. So our solution, okay, since the -4 is included in our answer, we actually can write this as one full solution from -infinity all the way through to the 2. And the 2 gets a bracket. It's included. It's a closed circle. Now, if, for example, the -4 were open and the 2 were open, then you'd have to do it as 2 separate intervals because you'd have to skip over the -4. So you'd have to do it then from -infinity to -4, and then from -4 to 2. You'd have to do it as 2 separate intervals then. But since the -4 is included, we can do it all the way across this entire interval in one shot. Okay, there's our answer. All right, we got one more. We're going to put this in standard form first. We're going to move the 4x over, add the 12. We'll do them both at the same time. Write them in order. We have x cubed minus 3x squared minus 4x plus 12 is less than 0. And now we're going to have to group it. It's got 4 terms. So x squared is a GCF. Leaves me with an x minus 3. -4 is a GCF. Leaves me with an x minus 3. We can factor out the x minus 3 times the x squared minus 4. Okay, now the x squared minus 4 will factor again. You should factor it again. You get x minus 2 times x plus 2 is less than 0. Let's find those zeros. So we want x minus 3 to be 0, x minus 2 to be 0, x plus 2 to be 0. So we get -2, we get 2, we get 3. There are 3 zeros now. So let's take this number line here. We have -infinity, positive infinity. Let's write them in order. We have -2 first, then we have 2, then we have 3, and we make 1, 2, 3, 4 intervals now to work with. We're going to have to test in 4 different intervals. -infinity and -2. Let's just try -3, -2 to 2. 0 is a great choice. From 2 to 3, we'll try 2.5, 2.5, and then from 3 to infinity, we'll try 4. And we are testing it, okay, in this one. I'm going to test it down here. I think that's the easiest one to work with. X minus 3, x minus 2, x plus 2. Okay, here we go. We're testing x equals -3. So -3 minus 3 is a negative. -3 minus 2 is a negative. -3 plus 2 is a negative. Negative times negative times negative is a negative result. This result here is negative. Let's try 0. 0 minus 3 is negative. 0 minus 2 is negative. 0 plus 2 is positive. Negative times a positive is a positive result. 2.5. 2.5 minus 3 is a negative. 2.5 minus 2 is a positive. 2.5 plus 2 is also a positive. Negative times positive is a negative result. One negative. And then x equals 4 we'll test. 4 minus 3 is positive. 4 minus 2 is positive. 4 plus 2 is positive. 3 positives gives me a positive result. We want to know where this inequality is less than 0, so it has to be a negative. That's there, not there, there, not there. It's less than 0, so it cannot be 0. Open circle, open circle, open circle. My solution is two intervals here. We have negative infinity to negative 2 in the union with 2 to 3. And that's the correct answer. This is all done. Okay? And that's all there is to it. All right. And as always, thanks for clicking.